Hello everyone. So to start off this unit, you can look at your digital notebook. This is Unit 3 Reactions. Make sure you insert your name, and this is second block. Here is the table of contents. So for Thursday, you'll be balancing. On Friday, you will predict and do the types of reactions. On Monday, you'll do rate of reactions, the oxidation reduction reactions. On Tuesday, you'll notice there's nothing here in class. That is when they're doing the ACT practice test. So if you are not doing the ACT practice, which if you are virtual, you probably won't be, you could just use that day to help catch up. There will still be a daily question, so you will still need to do that. And then Wednesday will be the third lab. So the test and the notebook check for this unit will be on Thursday the 27th. All right, so the first thing we're going to talk about is balancing. So your topic for this section of notes is balancing, and your goal is I can balance chemical equations. So before you can label a chemical reaction, you need to know what a chemical reaction is. So there are different ways to tell if a chemical reaction has happened. The first one is energy is absorbed or released, or the temperature gets hotter or colder. Color change can sometimes be a indication. Gas production, if it's bubbly, fizzy, or if there's like a smell change. A precipitant is formed, or a solid that separates from solution and won't redissolve. So here is an example of a chemical formula. You can have a reactant and then plus another reactant, and then the arrow points towards the product. That arrow means react to produce or yield. And then, of course, it's pointing to the product. Of course, you can have more than one product. In this example, there's only one. So some common symbols you'll see in equations. You have a plus sign that separates two or more reactants or products. You have the single line that separates the reactant from the products. You may see something where there is a line facing both directions that separates reactants from products and indicates a reversible reaction. If you see the letter S, that identifies a solid, L identifies a liquid, G identifies a gas, and AQ is aqueous, which means it is dissolved in water. So how to count atoms. Remember, when taking notes, you only have to type or write out what's underlined. If it is red, then you do need to underline or highlight it because that will be a vocab. So the first is subscripts. Each subscript tells you how many of that specific element there is. So for example, H2O. Well, you see that 2, the little 2, next to the hydrogen tells you there's 2 hydrogens. There's not a number next to the O, so it's known to be 1. Coefficients. It tells you how much of that compound you have. You have to distribute that coefficient to all the elements in that compound, or you have to multiply it by all the elements in that compound. So that first example, you have 2CO. Well, that 2 will go to the C, and that 2 will also go to the O, which means you have 2 C's and you have 2 O's. Now, the next example has 2 H2O. Well, you would do 2 for the H. You would do 2 times 2 because of the little 2, so that means you have 4 H's. And then you would do 2 times the oxygen, which there's only 1, so 2 times 1, which means there would be 2 oxygen. So how to balance an equation. Step 1, list the elements being used under the yield sign. Step 2, count how much of each element on each side you have. Step 3, change or add coefficients until the elements have the same amount on both sides. Never change the subscripts. So you're not changing the compound itself, you're just changing how many or how much of the compound you have. So you're only changing the numbers up front. So in the next video, I'm going to do some example of balancing for you all so you can see the different steps in action and how you balance chemical reactions. Okay, so now I'm going to go over some balancing examples with you all. So here is a reaction. F2 plus Li makes LiF. The first thing you need to do is under the yield sign, list every element you have. So in this case, we have F and we have Li. Second step, write how many of each element you have on each side. So on this side, we have 2 F's because there's a 2 right there. On this side, we only have 1 F because there's not a number. For Li, we have 1 on this side and we have 1 on that side. Okay, you've got to make sure these numbers are the same on both sides. In this case, F is not. So what can we put in this blank? What times 1 will make F 2? Well, if we put a 2 there, that'll make F 2. But that'll also make Li 2 because this 2 goes to both elements. So now Li is not balanced. So what do we need to do on the other side to make Li equal 2? It would be put a 2 in front of Li, and now everything is balanced. So let's do another example. Let's do Fe plus O2 makes Fe2O3. So first we list our elements Fe and we list O. So first we have to put how many we have on each side. So right here we have 1 Fe, here we have 2, here we have 2 oxygen, here we have 3 oxygen. So one thing I want you all to know, here you have a 2, here you have a 3. There's nothing times 2, a whole number, that'll give you 3. So you know you're going to have to do something to this one as well. If you make it even, then you'll be able to put a number on this side. So in order to make that even, we make it a 2. So now we have 4 Fe and now we have 6 oxygen. So what times 2 is 6? Hopefully you said 3. 3 times 2 is 6, and so that would make oxygen even. Now iron or Fe we still need to make even. So we have 4 on this side. What times 1 equals 4? That would just be a 4. So that's how you would balance that one. Now this last one I want to balance with you is C6H12O6 plus O2 makes H2O plus CO2. All right, so you notice oxygen is in multiple places on both sides. Whenever we list them and whenever we count them, save the element that is there multiple times for last, because most of the time it'll kind of work itself out and it'll make your work a lot easier. So on this side we have 6 carbon. On this side we just have 1. This side we have 12 hydrogen. This side we have 2. Now here, since oxygen's in multiple places, you'll need to make sure to count all of them. So you have 6 right here plus 2 right there, so that would be 8. Here you have 1 plus 2 right there, so that would be 3. So with this, let's go ahead and balance carbon first. So what can I put in front of CO2 to make it equal 6? Well, you would put a 6 there because 6 times 1 is 6, and that makes that even. But see, that changes your oxygen. Now you have 6 times 2, which is 12, plus this 1 oxygen over here, so that would be 13. All right, now on this side, nothing's changed yet. Now, so let's go ahead and jump down to hydrogen. Remember, we're saving oxygen for last because it's in multiple places. So here, what times 2 equals 6? Sorry, equals 12. That would be 6. So now we have 12 hydrogen, but that's going to change our oxygen. So now we have 6 times 2, which is 12, plus 6 times 2, which is 12. 12 plus 12 is 24. All right, now over here, we have 6 oxygen right there. So 24 minus 6 is 18. So we have 18 oxygens that we need to fill in this spot right there. 18 divided by 2 is 9. So you would put 9 right there. 9 times 2 is 18, plus 6 is 24. So since we saved that for last, we were able to work that out much easier than if we try to figure that out first. Those tend to be the hardest reactions to balance, the combustion ones. If you need help, or if you want more practice, or if you want me to go through more balancing with you, or if you get stuck on your practice page, or you just want me to check your answers for you, let me know and I'll be happy to.